Hey guys, welcome to the first video of the new year. I'm excited to film this brand new video to kick the year off and kind of get ourselves started with videos. And the videos will generally have sections for vocabulary, problem solving tips, and examples. Some sections will be missing for different videos based on what's covered, but that's our general kind of structure. So let's get it going. First is variables and expressions, so section 1.1. So we'll first go through a couple of vocabulary words. And the first one is terms. So when you talk about the terms, in an algebraic context, it's a number, a variable, or a product quotient of multiple numbers and variables. So the key here is there's nothing adding or subtracting. It's only a collected grouping of stuff, so to speak. So like a number, just 3, that's a term. Or a variable like x, that's a term. Or any combination like 3x, that's a term. Or 5xy, that's a term. Or negative 3x over y. These are all examples of terms because they're combinations of numbers and variables that only have multiplication and division, but no adding or subtracting. If you want to get into adding and subtracting, we move on to our next one, which is algebraic expression. When you take these individual terms that we had above, which are all these circled ones, and you add or subtract them together to each other, you create an algebraic expression. So 3 plus x, that's an algebraic expression with 2 terms. 5x squared minus 6y. That's an algebraic expression with 2 terms. 1 plus x plus y squared. That's an algebraic expression with 3 terms. In all cases, you can see that we've got these pieces added or subtracted together. A variable is what we use to symbolize anything that doesn't have a specific number or value, or it's an unknown number or value. You can use any letter of the alphabet to represent your variables. We will use X most often in this class, but you'll frequently use Y as well, or A, B, and C, or K, or Z, or anything you want. So if you don't know the value of it, you can just use any kind of letter to represent that. What I recommend you do is watch through like one slide and then pause the video so that you can copy it down and then resume playing. So go ahead and pause the video now, copy this down, and then come back and move on. Okay, second set of vocabulary for section 1-1, the factors. So when you factor something, you're figuring out what all the numbers are that multiply together to give you that number. You're probably used to drawing a factor tree. So for example, if you have 20 and you do a little factor tree, you can say that's 5 times 4. And then the 4 is a 2 times 2. So the factors of 20 are 2 times 2 times 5. You can do the same thing with variables. We are going to learn a lot more about that this year, but just in general, what it means when you say what are the factors of a number is what are the things that multiply together to give you that result. And then the result of multiplication, this is like the same thing in reverse. The result of multiplication is called the product. So the factors of 20 are 2, 2, and 5, and 20 is the product of 2, 2, and 5. So in one direction, you're finding the factors, in the other direction, you're finding the product. The next 3 all go together. The power or exponent, the base, and the coefficient. So let me just kind of put a little example here. 5x to the 4th. So the power or exponent is the 4. The base is the x, and the coefficient is the 5. So the coefficient is a number in front of an expression. The base is the value which is getting repeated over and over and over. And the exponent is the number of times you are repeating it. So this would be 5 times x times x times x times x. So the power of a 4 tells you to repeat the base 4 times, and that base in this case was just an x. So all powers, bases, and coefficients typically go all together for exponential expressions. Once again, I recommend you pause it so you can take a second to write this stuff down and then resume. We'll finish this chapter or this section off with some quick examples of applying these words and vocabularies to some simple expressions. So convert these expressions into sentences. So what we're going to do for these problems is actually write out in English what this means. So it's 3 times a number. So when you have an x there, it's just representing some unknown value. So you can say like 3 times a number minus 5. Another way you could write this would be 5 less than 3 times a number. Both of those are good ways to do it. Anytime you see something that says 5 less than, it means subtract 5 at the end. Number 2, over here we can say, here we have 2 things. We have 8 added on to some expression here. So we can say the product of negative 5 with the sum of a number and 2 added to 8. Or maybe even better would be to say 8 more than the product of negative 5 with the sum of a number and 2. So they can get really wordy. I know this is probably super annoying. I'm not a fan of these kind of problems, but I do recognize that it's important to be able to translate back and forth to understand word problems. So going the other way is way, way easier. If they give you the sentence and you have to write the expression, it's much, much quicker. The sum of 5 and a number squared. So sum means add. So it's going to be 5 plus a number squared. We can just call it x, and squared means like that, times itself. Last example, then we'll close this video out. 7 less than the product of a number and 6. So 7 less than means that we're subtracting 7 at the end. And what are we subtracting 7 from? A product of a number and 6. So that's an x times a 6. So we can write like 6x minus 7. So translating back and forth between equations and words helps show your fluency with numbers. Again, maybe pause it, write down these examples. But also for the example page, you can always pause it before I show the solutions and try to figure them out for yourself as a great exercise. So that's it. I'll see you guys in class if we're not already watching this in class all together.